Welcome back to this tutorial. Today, this is going to be our third module in the series of Mikrotik Training for Community Network Engineers, and I'll be taking you through this. Today, we are going to look at Mikrotik logical interfaces, how the physical interface interrelates with the logical interface, and the reasons why at times we have very many logical interfaces as compared to physical interfaces, how we can create, manipulate, delete, configure all logical interfaces. We are going to consider doing VLANs, point-to-point protocol interfaces. We are going to do Ethernet interfaces and creating virtual Ethernet interfaces. On the same time, we are going to look at how we can create bridge, how we can link up bridges, looking at port isolation, switch functionalities. I hope this is going to be a very interactive class you are going to learn. And please, if this is your first time getting into this, I'll encourage you to also watch my first and second tutorial on Mikrotik Training for Community Network. On the second tutorial, we looked at how to access Mikrotik interface, and we look at different tools that you can use. One of them was using the Winbox tool, and then we also looked at how we can access the Mikrotik using terminal, console, SSH, and telnet. We also looked at how we can use web config to access router OS interfaces. In the module 1, we just looked at the general overview and different categories and series of Mikrotik routers. And I think having watched these ones, you are fit to continue with module 3. In this module, we are today to do more practicals, where we are going to look at how interfaces are created, how interfaces are configured. So ladies and gentlemen, allow me continue. So some of the logical interfaces that we are going to interact with today is the Ethernet interfaces, where we are going to be able to create virtual Ethernet interface. We are going to look at different states of the ports of interfaces. We are going to, look at the SFP modules interfaces, but this requires that you have a device which is operating on SFP mode. We are going to look at VLANs into details, WLANs. We are going to look at LTE and bridge interfaces. Then we'll go ahead and look at how we can create a bridge, add a bridge, manipulate bridge, and work with bridging. And finally, ladies and gentlemen, we are going to look at PPP servers are working. That is point-to-point protocol, how we can use it to manage traffic and bandwidth. And going forward, we look at the switch functionalities in this module, where we look at things like port isolation, port forwarding, port aggregation, port merging, and switch rules. I'm going to use primarily in this tutorial Winbox to access my router OS and to perform practical classes. So this is my router, and when I log in, it normally brings me back to the point where I left the session active. But meanwhile, you can clear everything and you start from on a blank working space. Module 2, we talked of different parts of router OS, and the brown stage here or space is called the working space. We will be looking at the interfaces, and if you click on the interfaces, you will see various different types of interfaces that we have. For example, we have bridges, we have Ethernet interfaces, we have WLAN. So we realize that we can create very many other interfaces, including IOP tunnel or tunnel, IP tunnel, GRE tunnel. We can talk of VLANs, VRRP, bonding, bridge, mesh, virtual Ethernet, PP server, PPP client, PPPTT server, among very many other virtual interfaces that we can create. But for this, what is an interface? An interface is a point or part of a device that allows to allow services to pass through, either logically or physically. So, for example, if I say physically, if you remember that we have an interface, a point of intersection or a point of interaction with different types of modules. In this case, we have three interfaces already running. But before we get into interfaces, the logical interfaces have states. For example, we have a state, a port either running or a port being on slave or listening mode, or a port is having both. So for example, if you look at R indicates that the port or the interface is active and running, meaning there is traffic passing through that port. And if you see a port indicated as S, then that means that it is on the slave mode. And if a port is on slave mode, physically the port is active, but logically the port is inactive. And it is waiting. Like if we just plug in something on port 3 or ether 2, the port state will change from slave mode to running mode. In some routers, on some devices or vendors, we normally say that a port is administratively down or a port is administratively up. The word administratively is used to indicate that the logical state of that port. Remember, you can create a port on a device and make it logically inactive or logically active or administratively down or up. So now, that will not mean that if you look at your router or your switch, you will not see it indicating. It will be blinking, it will be showing that it receives power, but logically it does not allow any service to pass through. Then we say that port is on a slave mode. Now for WLAN, there is a difference because you can see we have here RS. The port is on two states, which is so amazing. The port is either running or on slave mode. So the reason why the port on WLAN is on two mode, one, because there is some connection that is already going through, and because it is a wireless interface, it keeps on scanning, it keeps on being on the slave state to keep on, looking for who wants to get in, which device wants to connect, so that it can get in. Remember, if it is fully on R state, it means the port is already in use and cannot be used by another device. So that is why wireless LAN always remains on the running and slave state. Running meaning there are some devices, there are some connections that already has been established, and the link is or traffic is passing through. And on the slave state, meaning that there are still other slots that are remaining for other devices to connect, and that is the state that will automatically be optimized or set. And then we have another state where we call X or disable. For example, if I click on interface 3 and click X, you see now there another state that comes in is XS. So X meaning this port is active, meaning physically it is working, but logically it has been deactivated. So therefore, if you are plugging something or you are plugging a cable on that port, the port will blink, yes, but the port will not transmit or will not allow any kind of activity to go through. because it has been administratively shut down. Remember, now we have three different states. So we have running state, we have slave state, and disabled state. For you to enable, you just select the port and then you check. It will come back to slave. I hope that makes sense. Now, let us go and look at the difference between interface and the interface list. So why do we have an interface and interface list? Now, interface list is formed when configuration starts. If I have to clear all the configuration files that I have, then there is high chances that I will also lose the interface list. So interface list gives you some configurable configuration details showing you that all LAN are on what kind of interface. For example, my LAN is running on a bridge, interface bridge, but it is listed under LAN. Then one is running on Ether 1, and of course it is on the list of 1. So you remember, you can create very many lists and you can assign them different interfaces. Then each list can do different things. For example, I can have one just to indicate that this is, maybe I have two different ones coming in, maybe port Ether 1 and Ether 2. So I can say, I can create one, the first one and the second one on different interfaces. Then there is now what like filter out everything, and that is Ethernet. So Ethernet typically just give us like a list of ports that we have. If your device is a 24 port device, then you will see all the 24 Ethernet ports, and Mikrotik labels Ethernet ports as Ether. Some like Cisco, Huawei, and others will do different naming styles. Some just do ETH, that's ETH, and others are just doing ENO, Ethernet. So it depends, but for Mikrotik purpose, for our class, it will be labeled as Ether. And now, there is something that normally applies to Ethernet ports, and that is called power circle. If you are asked to do a power circle, or you want to do a power circle, it is just a logical way of rebooting all the Ethernet ports back to restarting your router, but on a more safe mode. So if you hear someone is telling you, please power circle your device, or when did you power circle, it's just to do a soft safe booting or reboot of your device to check on, maybe if the traffic is too much, you can offload the traffic and restart. Now, looking at the Ethernet ports, I remember now this one is a bit advanced, but you know that mostly if we do configuration, the maximum transfer unit of a port is normally 1500. So 1500 is the maximum transfer unit that of packets that we can pass through. But again, if you have the reason why you need to change this, then you can do your changes. And then remember, when you are on the interfaces, you could see traffic on on two sets of interfaces. One, we were having the traffic flowing here at the bridge, and at the same time you have the traffic on Eth1 and the traffic on wireless. Remember? But when you come to Ethernet, then you are only seeing traffic flowing on Eth1. The reason being, this one is only Ethernet interfaces. And these Internet interfaces, the only one which has a running traffic is Eth1. That is where we are receiving our network, our internet from the ISP. So please note that apart. Then I want us to see how can you use this interfaces as a tool to know what is going on or what's happening on your interfaces. Maybe you are realizing that your CPU is overutilizing and you are just wondering whether it is the traffic that is going through a certain port or there is some malicious activity. So if you click on this lower drop down on the far right, you'll see show categories or show detailed mode. So if I show categories, it will just give me like ethers. I think here we only see one category, which is on E, and that is Ethernet. But for me, I want to see the detailed mode. So if I click on the detailed mode, I'll see different things that are happening on each particular interface. For example, this is interface 1, and interface 1 is ending here, the one which has been highlighted in light blue. So we can see that the name of this interface is ETH1, and it is of type Ethernet, and maximum transfer unit is 1500, but actual is 1500. And you can see the traffic is going link down and up and transmittable and all those things. You can see there is a lot of things that you can now be able to know on this particular interface. So if you had some problems, maybe there are packet drops that are happening anonymously and you're wondering what and why that's happening, you can just come and look at the errors that you see on the interface. So remember, we have a lot of things. We have the Jabber, we have the pause, we have the excessive collisions, we have deferred, we have the dropped packets, we have the short packets. So you have a lot of things that you can get to know. You can even see the fragments and multicast, so that at least you can analyze into details. Remember, when you're talking about the frame check, the CRC, you can always know like whether my port is the one having anonymous requests or these requests are within the LAN. When you are dealing with these interfaces, it is very important that you do your proper documentation. And actually, documentation does not really mean that you go, and write everything on your notebook or your documentation file. But it is also very important to do inline documentation, and that we normally call it inline comment. So the reason why we do inline comment is to allow us understand our interfaces. For example, if you see dot 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 dot, then dev conf. The dev conf is by default configuration, which just means default configuration. It denotes that the whatever configuration that you're running here are on default, and therefore you can make your own. And therefore, I want us to see how if you were to comment or document Ether5 as our, let's say, PPOE server port, we'll go and double click on it. And once you double click, it will open up, different functionalities. And then on Ether5, of course, you have the will to change the naming. But why must you change the default naming of Ether5 to maybe 5 or 6 or something, rather than just going to comment and you put your comment as PPOE or PPOE server. So then you click, and once you click that, it is already reflected here. Click apply and OK. So already you can see that Ether5, if we were to do advanced configuration, remember, labeling does not, or comments does not affect your configuration settings, but it gives you more clear understanding on what happens on what particular interface. So for example, now we know that Ether5 will be responsible for PPOE server. So if we were to set a PPOE server, we just need to tag it to Ether5, and we'll know that, okay, all services running through or passing or traffic going through Ether 5 is actually our, coming from the PPPoE services or traffic line. So that makes it a bit more sensible. And then there are some ways you can also troubleshoot your ports or your interfaces. For example, if I go back to Ether 5, double click, you'll see on your right that there you can particularly power circle a certain port, not only every port, and without even shutting down or rebooting the whole device or the whole router, you can just go and do a power circle or reboot a certain port. So if you double click on that port, you'll see these other things. You can do a torch. A torch is just to see what is happening. So it will give you different traffics that are going through, from which port, from which source to which destination, and such and such. Let me try that with WLAN 1, where we have the traffic so that we can see. Let me see if we can do a touch on Mac and also protocols. And let me stop and start. So if you look at this, you'll see that there are a lot of traffics that are going out, and it shows us the port, the protocol which is going out. Like I'm seeing here UDP, TCP or 6 on ETH protocol is 800 IP, RIP. Yeah, so those are things that you can touch and see. But again, I was not supposed to, touch my own network. But that is what is going on. Then you can do a cable test. For example, you are not really very sure with your cable. You can just click and do cable test. It will measure and tell you, okay, the cable that you are using is either too long or too short. I think I can try this on, let me see, on Ether 1, which I have the cable, and do the cable test. Think I can try that. Okay, no. This one is my ISP line, so it can't do that. But if you had, for example, you had a cable coming maybe from your laptop to the other switch, or from switch to router, you can actually do the cable test to know the status of that. Like for now, we don't have, there is no link, but it will give you parameters or all those things that you want to know. And finally, I was telling you that you can blink it. Blink it is just to make sure is it active. By blinking it, if you press blink, the ports will indicate like 1, 2, 3, 4, pop, 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 pop. It will show some lights, and then that will tell you that, okay, the port is active and can be used. I think that is what I wanted to say on the interface. But remember, there is a difference on MAC addresses. So each port has a different MAC address on the LAN side. On the one side, MAC address is the same. Now, I want us to look at the bridge as another logical interface. How do we allocate bridges? So we'll go to, I'll close this. I'll go to my menu. After wireless, there is bridge. So if I click bridge, I'll see how many bridges I have. For example, I have one bridge and it is commented as default. So by default, a bridge is created. And if you allow bridge to be created, it merge all the ports and put them in one bridge, unless you separate. So why do we need to separate, or why do we even need a bridge for instance? And as we speak about bridge, I know you understand that a bridge is used to link together two different domains of the network. And now, therefore, a bridge in this case will allow us to bridge different ports and bring them together and they will act as if they are on the same segment of the network. So for example, if I create a bridge, let's say bridge 1, and say okay, and then another bridge, bridge 2, and say okay. If I actually do port segment or port allocation to this bridge, ideally, these bridges can be created as domains of the network on the same device, remember? So for example, I can say bridge 0, bridge 1, and bridge 2 are different domains of the network. And therefore, if I come to ports, by default, you see the ports that are belonging to which particular bridge. So for example, I want to remove bridge port 3 and add it to maybe bridge 1. So what I say, I double click on it, and on the bridge, I'll select which bridge I want it to be. So I'll take it to bridge 1, and okay. Then 5, I'll also remove 5 and take it to bridge 2 and say, okay. So if you go back to bridge, you'll see that, of course, there is no traffic, and it will not tell you that these are the number of ports that are on this bridge and so on, so because it is just an interface. So, but what you'll see, if you go to ports, you will see that Ether 2 is on bridge 0, Ether 3 is on bridge 1, Ether 5 is on bridge 0, Ether W1 is on bridge 1, and Ether 4 is on bridge 2. And that is how it is actually. So if at all you don't want, you just need to delete the bridges that are there and the ports will go back to the default bridge. For example, if I click on this bridge 2 and delete, bridge 1 and delete, if I go back to ports, they need to be on the other normal bridge. Like for example, this one is telling it is an unknown bridge. So if you click there, it will just tell you, take it back to the normal bridge. And that is how bridges, how we can add a port to bridge. Now, the other thing that we need to see on the bridge is also what we call port extensions. Port extensions meaning I have bridge 1, bridge 2, or port 1, port 2. I can decide to extend a port or to control that port. So for example, if I have to do a port extension, then I choose a switch, let's say switch 1. I'll show you where the switches are found. And we want to control this port on a particular, control a particular port and maybe exclude other ports. Let's say we are excluding port 2. Then if you apply, automatically on the switches side, you will not know, but on the switches side, you will see, because we have not created a switch, so it can't really reflect. But I'll show you where there is a switch. Actual switch is here. So if you come here, you'll see all those things that I'm talking about, but that is not for today. But I'm just saying you can extend or control a port from the bridge side. Now, what about the VLANs? VLANs are very important. You can actually add a VLAN to a bridge, but before you add a VLAN to bridge, it is very important that you create a VLAN as an interface. For example, let me just go back to interfaces here and go to VLANs. So I can create a VLAN, and remember, VLANs are used to protect your private network or private LAN from the global network or from the internet. So VLAN acts in between. And then there are two things that are very important in the VLAN stage. So one, you have to know the VLAN name. You can say VLAN admin, VLAN whatever you want to name it. So you have to know the VLAN, and it is a best practice that if you are creating VLAN 102 or 112, then please indicate VLAN ID to be 112 for a purpose of proper documentation. It has no effect actually. You can even call the VLAN XX, but you give it a different ID. We can call it VLAN data. you can give it a different ID, but for purpose of proper documentation, because you can be creating very many VLANs, and let's say VLAN 100, VLAN 1, VLAN 10, VLAN 0, all those. So then you apply and create. Okay. So already we have our VLAN. And just as an interface, it will have all the TX, RX, FP, FPRX, all those parameters that you can use, and even MTU to, to indicate that it is just a virtual interface. Then now, assuming we have our VLAN, if I go back to Bridge and go to VLANs, and I want to create a VLAN, I will come here and input the VLAN ID that we created on the other side. And if we need to tag, which port are we tagging this VLAN to? That is very important. The port that we are tagging into the VLAN to is the port that has the service as the routing capability. So for example, maybe that is the port where the cable is getting into. It can be port 1, it can be SFP, it can be anything, but so long as it has a service that we want to tag to that particular VLAN. And then we say apply and okay. So by default, our bridge is tagged to a VLAN, and that VLAN can again, now our bridge can act on behalf, or our VLAN can act on that kind particular bridge. Now, I'll remove that. The other thing that I want to look at is the NAT. Remember, when you look at the OSI model, we have 7 layers. And we know that at layer 3, that there are different set of protocols as compared to layer 2. But now, how do the services translate from layer 1 to layer 3? Or from layer 2 to layer 3? How do we move from the physical layer, data link layer, up to network layer until we reach the applications layer? There are some protocol translations that happen. The frames change even its state from frame, or from signals, or from zeros and ones of signals to frames, from frames to packets, from packets to all those things. So for us to know that, it is very important that we understand NATing, and this is an area that we are going to look into details in our next coming classes, where we'll handle NAT or NATing as a lesson, to see how NATing is happening, and how MAC addresses translate to IP addresses until we get the service that we want. So allow me to do the last thing on interfaces on Ethernet, and I want to create a virtual Ethernet. So if you go to interface, I'll go and create virtual Ethernet. So virtual Ethernet will just behave as if it is a physical Ethernet port, and then just say okay. So under the virtual interfaces like WLAN, I have V1, VF1, that is virtual interface, or we have virtual interface 1. And this one, you can actually configure it as other ports that we have, like port 1, port 2, port 3, and it normally comes with a traffic analysis, which becomes different status, and that will allow you to extend some functionalities if a port is not really, you want to merge ports and add them to a particular virtual interface. That is possible, you can do. And I'd really want to stop there, ladies and gentlemen, for today's class. And please remember to revisit this as many times as you can. And if you have any questions or any comment, please feel free to leave them in the comment section below, and I'll be able to look at them, do research on them, consult on them, and also give you feedback as soon as possible. For more details, you can also drop me an email. I'll leave my email on the chat, on the comment section below. And please feel free to share this content. You can like and also subscribe to my channel, so that in case I do a new video, you will be updated or notified on the new video. Thank you and have a nice time.